Hey there, welcome back. All right, in this module, we're going to talk about the waste of defects. Specifically, by the end of this module, you'll know what defects are, what they cost us, what causes them, and some tools we can use to eliminate them. And as promised, we'll see what Isaac is up to over at RAM Technologies. So let's start things off by learning exactly what we mean when we call something a defect. Well, formally defined, a defect is any work that is less than the level the customer has requested. And these defects ultimately plague our companies in various ways. And while it's very difficult to accurately quantify this cost of poor quality, as it's often called, we can attempt to measure its impact by looking at things like warranty costs, lost capacity, rework costs, field service repairs, and last but certainly not least, customers can be lost due to poor quality. And ultimately, our ability to detect defects can dramatically impact their cost to our companies. In fact, it's estimated that each time a defect is passed on to the next process, it takes 10 times more money to fix. In other words, fixing a problem early on is far less costly than fixing it one or more steps after the error has occurred. And even if you can't seem to completely eliminate the cause of the defect, the next best thing is to develop a system so that you can immediately detect them, since by detecting problems earlier, it allows you to go for the simple solution, not the perfect one, while slowly advancing towards perfection. Now, in the future, Gemba Academy will offer formal Six Sigma training, where we'll spend a lot of time talking about ways to prevent defects. And during this training, we'll talk about whether 99% good is good enough. And while we won't go into great detail here in this module, let me just say that the short answer is no. 99% good is not good enough. In fact, if all pharmacies operated at 99% performance levels, meaning 1% are bad, they would actually dispense 20,000 wrong prescriptions each year versus around 68 per year at Six Sigma performance levels. Likewise, operating at only 99% performance levels would equate to 2 short or long landings at the Dallas-Fort Worth International Airport each day versus 1 short or long landing every 5 years if they were operating at Six Sigma levels. Finally, if the Postal Service only performed at 99% defect-free levels, there would be around 400 lost articles per hour versus 1 lost article of mail per hour if they operated at Six Sigma levels. Now, these are just a few examples demonstrating how much we truly depend on certain processes to function at extremely high performance levels. Now then, let's switch gears and spend some time talking about some potential causes of defects, which will then lead us into some discussions on potential countermeasures. Now, the first potential cause is the lack of in-process checks. And as we've already discussed, our ability to detect problems early in the process is crucial, since the longer a defect is allowed to move through the process, the more it costs us. Another common cause of defects is low quality material from our suppliers. In fact, some companies spend millions of dollars reworking things like castings, as shown in this picture, before even thinking about adding value their customers are willing to pay for. Finally, some other causes for defects are inadequate training and poor or no work instructions. And as we see here, Isaac is really struggling to make a good part. And it seems his work instructions are poor at best, and the training he's been given is severely lacking, which in the end is resulting in the creation of many defects. Okay, well, now that we've discussed what a defect is, what it costs us, and some potential causes, let's learn about some of the best tools and techniques we have to battle defects. Well, the first technique is the stop the line principle, which basically means all associates are empowered and, in fact, encouraged to stop the production line whenever a defect is detected in an attempt to understand and address the root cause of the problem. Now, many companies experienced with lean principles utilize andon cords, which are cables or strings that, when pulled, cause a whole line to stop after a short time. Another extremely powerful technique is called poka-yoke, also referred to as mistake proofing. The basic premise behind poka-yoke is that we make it impossible, or at least extremely difficult, to make a mistake or produce a defect, much like it's difficult to place a square peg into a round hole. Now, there are examples of poka-yoke all around us. For example, most printers make it difficult, if not impossible, to insert ink cartridges the wrong way. Likewise, many sinks and bathtubs come equipped with overflow holes in case a water is left running. The next tool available to us is 5 why analysis, which essentially has us asking why multiple times in an effort to identify the root cause of a problem. For example, someone might ask a colleague why they're sweeping up a floor. Well, the person sweeping might reply that their machine is throwing metal shavings onto the ground. From this, the questioning employee might ask, well, why is the machine throwing shavings? And this type of exchange of question and answer would continue until the root cause was identified, enabling a countermeasure to be implemented, freeing the operator from ever having to sweep this mess up again. Now, another powerful tool, and one we'll learn much more about in our Six Sigma course, is a fishbone diagram, where the defect is placed at the head of the fish, while all the bones of the fish are potential causes. In this example, we see that surface flaws is our defect, and the 8 bones or categories of potential causes has been drawn in, including personnel, material, measurements, testing, shipping, environment, methods, and machines. Then, together with the team, each category is investigated in order to identify potential causes of surface flaws. For example, when we look at the environment category, we see that moisture percentage and condensation are potential causes of surface flaws. Well, with this known, this team could assess how serious these potential causes were while then implementing some type of countermeasure. Next, as we've learned in the Introduction to Lean module, the second and sometimes forgotten pillar of the Toyota production system is Jidoka, also referred to as automation or automation with a human touch. Well, the basic premise behind Jidoka is that machines are able to detect when an issue has occurred. And once they detect an issue, the machine stops running while alerting the operator of the issue by flashing a light or sounding some type of alarm. Oftentimes, inexpensive sensors wired into machines' controllers are all that's needed to get started with Jidoka. Next, as we've already hinted at earlier, the use of Six Sigma is another powerful approach many organizations have used to battle and defeat defects. And finally, by arming associates with clear work instructions and standard work documents, their chances of producing defect-free products are greatly increased. Now, let's get back to our friend Isaac to learn what he and his associates have come up with in response to the defect problem he was battling. Well, as we see here, Isaac now has clear work instructions and is able to quickly and effectively do his job. All right, well, this wraps up this module on defects. In our next module, we're going to discuss the waste of inventory, which, in today's tough economic environment, is an extremely important topic. So, we'll speak to you soon.